Hello and good morning. It's the top of the hour, so I think we're going to get started here. Welcome to this webinar. It's all about getting started with performance testing. My name is Elizabeth Simons, and I'm a product marketing executive here at eggPlant. And I'm joined by Tom, who is a technical specialist in our Colorado office focused on eggplant performance. I think in all forms of testing these days, there's a tendency to focus on too much on tools and not enough on the actual end-to-end testing process. As you all know, there's a lot more to testing than simply coding up a test script and executing it. You need to think carefully about what it is you're trying to test, design your test, interpret your results, and feed those results back into your test design. I think this is particularly important in performance and load testing, where it's far less obvious what exactly you're trying to test and whether or not your test passed or failed. So in this webinar, Tom is going to walk through the step-by-step process of doing a performance test, exactly the steps we go through when we're doing projects with customers. Note that there's nothing eggplant performance specific about these steps. We'll of course use eggplant performance as an example, but you would use these same steps with load runner or JMeter. Before Tom gets started, I just want to point out that you have a question box in your GoToMeeting panel that will allow you to ask questions of us during the webinar. We'll answer all of these at the end over the broadcast for everyone to hear, but please feel free to ask those throughout the course of the webinar. So without further ado, I'm going to hand it over to you, Tom.
All right, thank you very much, Elizabeth, and thanks everyone for joining us today. So let's dig in. As is true with most complex undertakings, especially in an enterprise software setting, planning is king. There's a famous quote here that I was admittedly somewhat hesitant to use. It is known as the 7 Ps, but what you'll see in front of you now is actually the condensed version of that, featuring only 6 Ps, just so we don't get into any trouble here. You can probably guess what that 7th P might have been. So it's about proper planning, and preparation prevents poor performance. So this is, of course, very appropriate given that we're dealing with performance testing. And it is true to a T. There are so many variables involved in performance testing, so it's important that they're all accounted for. But before I delve into what all these variables are, I will point out that I probably won't be exposing every single one of these variables. That might take a bit longer than we have time for today. Instead, I'll just be talking about the bare necessities, the things you will always have to think about, regardless of what type of software you're testing. With that said, let's begin our journey. So in the performance testing world, this plan is aptly called the Performance Test Plan, or PTP if you're a fan of acronyms. So the purpose of the PTP is to encompass all of these different variables in a format that is easily digestible by its audience. And that audience can stretch all the way up to upper management, so it's important that the content is laid out in layman's terms as often as possible. At the very least, the performance test plan should define what the testing requirements and objectives are, the scope of the testing, and details surrounding the overall testing approach itself. Gathering test requirements is tricky business in and of itself. It requires an understanding of the business as a whole, as well as the architecture that's going to be supporting it. On the business side, one needs to have some idea of what kind of load is to be expected when the software is put into production. This is where the term concurrency comes into play. How many concurrent users are we likely to expect when we open our website to the public is a pretty classic example. Working out what this figure should be is a bit of a science in itself. In most cases, the total user population is a known figure, but how that relates to actual concurrency at any given point in time, which is what the tool is looking to find out, that might not be so obvious. Often you'll need to delve into log files to work out a more accurate figure. Data gleaned from tools like Google Analytics can really help build an accurate picture of how much your software is actually being used. Another business-oriented question that may need answering would be, well, which parts of the system should we focus our efforts on? The reasons here are twofold. First, this core functionality is likely the revenue-generating part of the software, or the stuff that would render your software useless if it wasn't working, and so it's important that those bits of the system are tested first. Secondly, as we'll see later on, time is ultimately going to limit how much performance testing you can actually do, and so you will be required to prioritize testing of the parts of the system that are most important to the business. Architectural questions might be, well, which parts of the system are most likely to cause bottlenecks? This is a bit more difficult to answer because these parts of the system might not necessarily be the same as those considered core to the business. There might be things like batch processes running overnight, performing some kind of cleanup routines. You really wouldn't want those running into the morning when your users start coming back online. The objective should also state the types of tests that are going to be run. It usually won't be a case of just running a performance test and that's that. You'll probably want to be running that same test multiple times, making changes on the server side in between each test run, so you can tell the difference that those changes have actually made. And performance testing involves running all sorts of different tests too, each providing unique insight that combined will give you the complete picture, and ultimately the confidence needed to release quality software. It's also worth mentioning what kind of constraints you may encounter. One of the harsher realities with performance testing is that there will only ever be so much you can test before you simply run out of time. Eventually, it'll become difficult to justify delaying the release of software any further on the grounds that you haven't managed to get around to performance testing some really obscure part of the system. Other constraints may be that your system relies on some third-party system that you have no control over, and may not even be allowed to performance test without some prior agreement that it would be okay to do so. It is important to make others aware of what is and isn't within the scope of the testing, along with the reasons why, and what potential performance issues those out-of-scope items may present to the system as a whole, so it should definitely feature in the performance test plan. A good example here is Salesforce. We hear a lot of customers wanting to test the performance of their Salesforce deployment, or more specifically, the customizations that have been made to Salesforce to have it interact with all of the various systems it pushes and pulls data to and from in your specific environment. But this presents a number of interesting challenges. Which environment are you going to run the test on? If it's a sandbox environment, how will you know how that compares to the production environment? If you're going to test on the production environment, you'll inevitably be putting load on Salesforce's own servers, and they might not be too happy with that. Should you include modules such as Chatter, the functionality that gives you the ability to chat to other Salesforce users? Probably not. It's fairly safe to assume that Salesforce have done their own performance testing and have ensured that the chat functionality is given lower priority and isn't going to interfere with your customizations. Or perhaps that's not the case. Lots of questions there. I hope you're starting to appreciate the need for proper planning and for there to be agreement on what the eventual testing is going to consist of. The performance test plan will also allow you to lay out your intended approach. That is to say, which software you are going to use to conduct the testing, what kind of test data your tests will need, and how you're going to go about generating that data. Sometimes you may even need to reset the environment you are testing against somehow. This is especially true if you're creating data of some sort. What about testing on an environment that features lots of already generated data rather than testing against an empty database? Eventually, the performance test plan will contain everything that's needed in order to perform the testing, and it'll have been signed off by stakeholders and you are ready to implement it. This is finally where the software steps in. In order to be able to conduct these kinds of tests, you need the ability to automate all manner of different protocols. But as important is a tool that has the flexibility to support all of the different variables we've just been talking about. Let's see how this plays out with eggPlant performance. What you're looking at now is the studio component in use, which is where all of the design aspects of performance testing takes place. The first step to developing your performance test is creating the scripts that will replace the need for real people sitting in front of computers doing stuff at the same time. That's just not a very scientific or accurate test. Automation is basically a requirement in this situation. The nature of these scripts will depend on what it is you're testing, and how they are created will also depend on it. For example, scripts simulate web traffic, namely the sending and receiving of HTTP messages, which is essentially what sits behind the internet. That involves using a browser together with a proxy recorder that listens in on that HTTP conversation, capturing it into a script. This is actually quite important because it could take a long time if you have to write this kind of script from scratch. And especially certain websites that can be very complex behind the scenes, especially if they've been generated by some kind of framework. WordPress is an example that springs to mind here. Salesforce is another good example too. The result of this recording is a script that will usually need some kind of tweaking in order to get it to do what you want. For example, you might have logged on to the website using a set of credentials. Those credentials would have made their way into that recorded script. So you would want to be able to modify the script so that you're instead feeding in login credentials from a flat file, where each virtual user can pick its own set of credentials from. One of the benefits of using eggPlant Performance is you will have the ability to define this kind of task using generation rules rather than actually modifying the script code itself, although that is perfectly fine as well. We build generation rules to make the computer do all those script edits rather than the end user, which ultimately gets you up and running with the script faster than if you were to do these manual edits yourself. Another common situation where this applies is the process of correlation. This is the task of taking some dynamic value that the server generates and sends to the client, and ensuring that the script uses this value rather than whatever was planted into the script during the actual recording itself. Automating this process allows you to get going quicker and in a much less error-prone way. This recording and script generation phase, if you like, can actually take a significant amount of time in the overall performance testing process, especially if there are lots of business processes that need scripting. But once done, you'll be able to use them for all manner of different tests, and sometimes even outside of performance testing altogether. A classic example is a script that creates a new user on your system. This kind of script will likely come in handy for your functional testing team too, because it's usually a very laborious task, and you've just automated it. So put people out of their misery and tell them you can do it at the press of a button, and they'll probably love you for it. Let's move on to test design. You've got your tests laid out in the performance test plan, and so now it's time to translate those into the tool. With eggPlant Performance, you've got all the flexibility you need to design all manner of different tests. The basics are having full control over things like how many virtual users you want to run, how long they should run for, how quickly they should ramp up to the desired concurrency, because you wouldn't want them all starting at the very first millisecond, and what kind of test data they should use, like which credentials to log in as. But there are lots and lots of other settings that I won't delve into too much detail here, but be assured we've got functionality to cover them all. Suffice to say that any of the tests mentioned on the first slide are all possible to implement in the tool, be it a soak test running for several hours or a stress test aiming to establish at what point the servers are no longer able to cope with the load being generated. Next up is the fun bit. Now you're ready to actually run your tests, and this happens in the second eggPlant performance component, namely test controller. You see it being launched here in this video now. So here you'll want to be able to look at what your virtual users are getting up to. So each virtual user will be maintaining its own event log, where you can view things like verification messages that you might have planted into your scripts during key transactions, as well as any errors that they might be encountering as well. Examples of useful message output we'll see in a little bit once this test starts up. It could be things like server-generated identifiers for example, when creating an order, it might generate a dynamic order ID that increments on the server side. That's usually a pretty good value to use to ensure that your script is doing what it should be doing. It effectively validates the whole end-to-end process. Along with these event logs, you'll also want to be able to get a feel for the overall health of the system you're trying to test. Now, hopefully you've configured server monitoring so that you can have a look at what's going on with the service you're loading as the test runs. This is where you'll start to derive value out of running these tests. You will not only be able to say, oh, my average response times were 5 seconds at 2,000 concurrent users. You'll also be able to say the web server was seeing CPU usage averaging around the 80% mark when we were at 2,000 users. So imagine then there was a requirement for the application to be able to support 3,000 users. That's going to cause some problems. So eventually your test will complete and it'll be made available to the third and final component, which is eggPlant Performance's analyzer tool. So at this point I was going to switch out of this video and show you Analyzer. If you want to see some more of Test Controller's capabilities, you can skip ahead here and you can see some of the other things you can do in Test Controllers. So this is the real-time view of what's going on with the test. We also have some features here that allow you to add extra users to your test while it's running. So this is, if you're under those time constraints that I mentioned before, being able to modify your test like this can actually save you a lot of time and allow you to run more tests. And the more tests you run, the better of a picture you have of the overall performance of your application. So I've now just dynamically added another 60 virtual users to the test. I think some of them actually ended up failing to log in this case, presumably because my processor usage was starting to go through the roof. So that's not a healthy level of load for the server to be at. I think it's approaching 90% average, which usually means it's peaking at 100%, and that's not a good place for a server to be. So let's have a look at the results of this test in the analyzer. So this is the third and final component, eggPlant Performance Analyzer. So here we have the information from the test, basically the same thing we saw in the video just now. But we can delve into greater detail because we've performed some post-run analysis on that data. So we have these rich charts. We can hover over individual series here to see which transactions relate to the different colors. So based on this, I can clearly see that confirm order is going, looks like it's the slowest transactions out of all of them. And I can also see that something seems to have started happening here. My response times have increased, whereas they were relatively stable at the start of the test. So in order to find out what's going on here, we should probably look at a bit more data. So let's bring in the virtual user concurrency chart. So here we see this is the ramp-up period. So my virtual users started ramping up over time rather than all at the same, very same second or millisecond even. That's pretty unrealistic. That doesn't really happen in the real world, but it is possible to design a test that would work in that way. But in most cases, you'll want to ramp up slowly to the concurrency you want to stay at. In order to give the server a chance to keep up with that initial load. So the load is usually a bit higher at the very beginning of a test until you reach your steady state. And so here we see the effect of adding those additional virtual users. The average response times have increased. I can hover over this combined transaction here. That is actually the average of all the other transactions. The black line there has been highlighted on the chart. So we can clearly see the impact of adding more virtual users on our response times, which is still generally quite good. There's nothing really that exceeds 2 seconds. But if you're a financial institution dealing in milliseconds, that could be a significant fact right there. As I was monitoring the web server itself during this test, I can add in all sorts of system under test metrics. So the most useful one there is usually the processor usage. This is the average CPU usage over time. So that's this middle chart that's appeared now. So I can see at the start of my test, I was averaging somewhere around 60–65%. Which is sort of veering on the high side. You probably want to have your server not be at that level consistently. It is an average you're looking at, so it could be that at certain points this was peaking at 100%, and that will definitely have had an impact on your response times. But we can see here 90% averages. That's pretty unhealthy level of load, and so that's likely why we're seeing these increases in response times. The virtual users are being, the transactions the virtual users are attempting to perform are being queued. I would likely see an increased amount of concurrency here. There's a lot more concurrency in the middle of the test. I was expecting to see more concurrency in the second part. Perhaps one reason why that's not the case is because the transactions are still completing fairly quickly. This isn't that big of a difference, but it did have a big difference on our CPU, so there's at least that. So another type of chart that you'll have at your disposal here is the table in this case. It's the transaction summary. So this is sort of the breakdown of all your individual transactions in the test. So we can see here this combined value is the amalgamation. So we've got 12,692 transactions that took place in total, and that broke down as follows for each of the individual transactions within that. So each of those transactions will have an average response time logged against it. Thanks to this heat map, we can quickly see that our slowest average response time is for the confirm order transaction, and it was just over 1 second. We've got minimum and maximum response times as well. So that's obviously quite useful to know if you've got a transaction that's always taking at least some amount of time. That could be interesting to know as well. Likely that will be a transaction that will suffer more than others when it's put under stress. So our slowest transaction there, it's just beaten by clicking on the checkout there. There's other values here, percentiles. So the percentile value is often used to exclude some particular response time. So the 95th percentile is very common, especially in the world of HTTP. There's the sort of, it allows you to say, well, we're going to ignore 5% of the worst transactions, given that these might be the one-off edge cases, and so this figure allows you to look at, well, what kind of response times should we expect most of the time. So that's what that figure represents. And then you've also got standard deviation. As well as transaction data, in the case of HTTP, we can go a bit lower level as well, which is incredibly useful. These transactions will likely consist of multiple individual URLs behind the scene, and so you'd want to be able to actually see the breakdown of those individual URLs as well. You may notice that by default we only show the worst performing transactions and requests. So there's quite a lot of requests that are URLs that are requested as part of a typical web-based load test, and most of the time they respond pretty quickly. Things like JavaScript and images, CSS files. They shouldn't really cause much of a concern for the web server, and so it's nice to just be able to exclude them. So this really focuses on what are likely the top level requests. So the actual search request itself, where the server has to dynamically generate a set of search results for you. those are the ones that are likely to cause the web server to use more CPU than requesting an image, for example. And those have charts associated with them as well. Other cool features in here, we have the ability to compare response times over time. So at the very first time I ran this test, my response times were very, very low. But as time went on and I kept running the test, perhaps more functionality was being added to the site, to the system I was testing, slowing everything down. Perhaps there was just more data on the system. And so over time, my response times have just increased, and so that's an important bit of information to have. Again, we've got the table view behind that, so you can actually see what the values, the actual raw values are themselves. Eventually, you'll have spent some time looking at all the different data. We have this little section here that allows you to add some notes, so you can explain what it is you're seeing, perhaps for your own benefit, but chances are it's more going to be useful for others who might be looking at these results without necessarily having run the tests themselves. And so these notes will actually make their way into the report that one generates. So this is the very last step of running a performance test, or could be still quite early on if you then discover lots of issues and you need to run this test multiple times. But the report, it's aiming to condense all of the information down into a single file. A Word report, something like that. We do have different formats, PDF and HTML as well. And that report should contain, all of the useful information that you, as a performance tester, will have discerned from this data. So I've got an example of a generated report here. This is the HTML version. So we see that we have our transaction summary. Looks very similar to what you just saw in Analyzer, and we have a whole bunch of other charts as well that that can be output as well as the notes underneath. So here I put in the chart shows the average response times for the 10 worst performing transactions. We also have a KPI feature, this key performance indicator, allows you to say, if the response times exceed 2 or 5 seconds in this case for a given transaction, then that KPI will have failed. I think we've got a little KPI table here. So I was monitoring things like what's my CPU usage. As long as it's below 75%, then the KPI passed. In this case, we got pretty much up to 100%, so the KPI has failed. So this is useful if you have service level agreements. There's an SLA that says no transaction should take longer than 5 seconds. And then you'd be able to render this chart and relay that to the audience of the report. And that's pretty much what you're looking to achieve, being able to put together a report that you then distribute to all the stakeholders, and that's more or less it. I think we have a bit of time for a few questions. So, Elizabeth, have we had any come through?
Yeah, we did have a couple come through. So I know we don't have a whole lot of time left, but I'll go ahead and throw these out here. There was one that came through that says, can you explain how to establish concurrent connections to the desktop application for performance testing?
Oh, that's an interesting question. So, it depends a lot on the application. Is I think the only answer I can give there.
Okay.
In a web environment, multiple connections is a bit easier because you can run multiple virtual users from a single machine, because all they're doing is sending and receiving HTTP messages. You might need to think about IP spoofing, so each virtual user might need its own IP address. We do have features for that in the tool, but when it comes to desktop applications, if you're actually going to be loading those desktop applications themselves, the actual user interface, the GUI, then you might need to think about setting up a terminal server where you can run multiple Windows instances or logged in sessions on the same machine. but there's lots of other things to think about in that situation. I'd love to talk to you more about that, whoever raised that question. It's a very good one, but it's so specific to the application that you're testing that it's hard to give an answer. I
Okay.
mean, in an ideal world, you'd want to be able to test that application at the protocol level, but then again, there's loads of questions there. In some cases, you might not be able to decrypt that protocol traffic, in which case you pretty much have no choice but to actually automate it through the GUI. So yeah, interesting question, but no straightforward answer, I'm afraid.
Well, we're running out of time here a little bit, but I'll just throw one more quick question at you here. We also had one come through that's how long does it typically take to create the automation scripts?
Yeah, so yeah, the scripting phase can, like I said, it can take quite a long time. Ultimately, it'll depend on what it is you're testing. But having worked with quite a few performance testers in the past, even consultancies, these are people who do the performance testing on a full-time basis for customers who don't want or don't want to own performance testing themselves. They would quite easily be able to suggest 2 business days per business process, 2 days per script essentially. So if you have a lot of scripts to write, then the amount of time that it takes to put all those together can actually be quite high, and it often can be higher than the actual process of running the tests and analyzing the results. So easily it could be 60% of your time, and you're only spending 40% of your time actually running the tests and analyzing the results. But like I say, it all depends on what's being tested. We have put a lot of functionality into the tool that attempts to reduce that scripting time, so you can spend more time focusing on actually running your tests and analyzing your results.
Cool. Well, thank you, Tom. I'm going to go ahead and close out the webinar here. But for any of those of you who had questions that we didn't quite get to, we will follow up after the webinar. And I thank you all for attending and hope you have a great day.
Thanks, everyone.